Here it says the braking distance in y feet for Damon's car to come to a complete stop is modeled by y equals this stuff, where x is the speed of the car, so x is the speed, y is the feet of the car in miles per hour. According to this model, let's check that out, miles per hour. According to this model, which of the following is the maximum speed in miles per hour? Okay, so now this one, where it says maximum speed in miles per hour, Damon can be driving so that the braking distance is less than or equal to 150 feet. So what we're looking for, let me read it one more time. The braking distance in y feet for Damon's car to come to a complete stop is modeled by y equals that stop, where x is the speed of the car in miles per hour. According to this model, which of the following is the maximum speeds in miles per hour that Damon can be driving so that his braking distance is less than or equal to 150 feet? So what we're looking for is y is less than or equal to 150. Now the easiest way to do this, we could do it algebraically, which would mean that we would say, we take this equation here, and we would say 150 is equal to 3 times x squared plus 10x all over 40. And then solve for x. And so I'm going to try to do this real quick, and then I'll show you how to do it on the calculator. So if I multiply both sides by 40, over here I'm going to say 40. This cancels with this. And then this is 60, I think that's 6,000. Yeah, 6,000 is equal to 3 times x squared plus 10x. And so then I'm going to divide both sides by 3. So I get 2,000 is equal to x squared plus 10x. And then what I could do is set it equal to 0. And so I'd have x squared plus 10x minus 2,000. And then you'd have to solve that. I would say 40 and 50. So in other words, what you would have to do is figure out this would be x and x because we have to factor it. So I think it's 40 and 50. So I'd have a 40 here and a 50 here. And then I've got to determine which one needs to be negative. Since my middle term is positive 10, that means that the 50 has to be positive and the 40 has to be negative. So this would give me a positive 50x minus 40x. And when you combine those, that gives me my 10x. And then when you multiply negative 40 times positive 50, I get 2,000. So what that means is that this right here factors to x minus 40 times x plus 50. Okay? And so then if I set each one of those equal to 0, I get x equals positive 40 and x equals negative 50. And so in this case, this is erroneous because I can't go negative 50. So the answer is probably 40. Now to double check that on the calculator, it would go a little quicker if we use the calculator. So let me just pull up my calculator real quick. I thought I had that on my desktop. Oh well. And I'll just take a second. All right, so let me clear this out. I got a bunch of stuff going on. I got a program I have to quit. And clear this out. Go to Y, clear this out. So what I want to do is I want to say 150 here. And then I'm going to plug in my other equation, which was 3 times the quantity x squared plus 10x divided by 40. And I want to graph and see where those two intersect. So I'm going to change my window a little bit. I know that the answer is between 40 and 50, so I'm going to set this from 20 to 60 for my x values. For my y values, it has to be at least 150, so I'm just going to go 140 to 160. Then hit graph. And so that line represents the y equals 150. And in a second, we're going to have a quadratic that should come through. And so this is the intersection that we're looking for. And if I did my math right, that should be 40. So I'm going to hit second trace for the calculate. We're going to try to find the intersection. And so my first curve looks good. Second curve looks good. Going to guess. And yep, when x equals 40, they both equal 150. And so any value less than 40.